Hi, my name is Hannah and I'll be doing the NURS2020 medication calculation timed assessments. Here is my student card. My number is 20162705. Alright, let's get started. So my first medication is 200 milligrams of ibuprofen. The dose is 400 milligrams. They're wanting to know how many tablets the patient requires. So if the dose required is 400 milligrams and the tablets come in 200 milligram tablets, you will need 400 divided by 200 is 2. So I'm going to place 2 tablets in the cup, check my answer, and that is correct. Alright, so the next one is chlorpromazine. The dose required is 50 milligrams, and it comes in 100 milligram tablets. So 100 divided by 50 is 2. No, hold on. Go back, sorry. Comes in 100 milligrams and we require 50. So that's half a tablet, which is correct. The next is cephalexin. The dose required is 250 milligrams and they come in 250 milligram tablets. So that means we only require 1 tablet, which is correct. All right, next is frusemide. We require 40 milligrams and it comes in 20 milligram tablets. So 40 divided by 20 is 2, so we require 2 tablets, which is correct. All right, the next one is allopurinol. We require 100 milligrams and it comes in a 100 milligram tablets, so that means we require 1 tablet. And that is correct. All right, we've got prednisolone. We need 30 milligrams. It comes in 5 milligrams. So I'm going to draw up in 1 ml. So 30 divided by 5 equals, we need 6 ml. And that is correct. The next one is oxycodone, which is in 10 milligrams, 1 milligram per 1 ml. So 10 divided by 1, we need 10 ml. And that is correct. Next we have chlorpromazine, 30 milligram dose in a 10 milligram over 1 ml. So 30 divided by 10 is 3 ml. Which is correct. All right, chlorpromazine. The dose is 50 milligrams over 5 milligrams over 1 ml. So 50 divided by 5, we need 10 ml. which is correct. We've got amoxicillin in 1,000 milligrams from 125 in 5 mils. So we're doing 1,000 divided by 125 equals 8 times 5 is 40 mils. Which is correct. We got gentamicin, 60 milligrams from 18 milligrams over 2 mils. So doing 60 divided by 80 is 0.75 times by 2 is 1.5. Which is correct. We've got diazepam, 10 milligrams is the dose required. It comes in 10 milligrams over 2 mils. So we're doing 10 divided by 10 is 1 times 2 is 2. So we give it 2 mil dose, which is correct. Okay, we've got benzitropine, 2 milligram dose in a 1 milligram in 1 mil. So 2 divided by 1 equals 2 times 1, which is 2. And that is correct. And we've got ranitidine, 50 milligram dose in 50 milligrams over 2 mils. So 50 divided by 50 is 1 times 2 is 2. Which is correct, sorry. Metoclopramide, 10 milligram dose, it comes in 5 milligrams over 1 mil. 10 divided by 5 is 2 times 1 is 2. Okay. Now we've got intravenous fluid treatment. Okay, so we've got a reviewing the IV fluid treatment chart and setting up the pump to administer the correct infusion rate. So this has got 0.9% sodium chloride in 500 mils over 6 hours. So the correct rate is 500 divided by 6. And running that to the closest mil is 83. And the volume is 500 mils. Just putting that into the pump, checking my answer, and that is correct. Next we've got gelafusine, 500 mils over 2 hours. So we're doing 500 divided by 2 is 250 mils per hour, and the volume is 500 mils, which is correct. Okay, next we've got 5% dextrose with 0.9% sodium chloride, 1,000 mils over 12 hours. So we're doing 1,000 divided by 12, and that's closest mil is 83. So the rate is 83 mils per hour. The volume is 1,000, which is correct. All right, next we've got 10% dextrose with 0.22% sodium chloride, 500 mils over 6 hours. So I do 500 divided by 6 is, and the closest is closest mil per hour is 83. The volume is 500 mils. Checking, and that is correct. All right, next we've got 3.75% dextrose with 0.225% sodium chloride, 500 mils over 8 hours. So I'm doing 500 divided by 8 is 62.5. So the rate, so 62.5, you round up, so you do 63. The volume is 500, and that is correct. All right, we've got 0.9% sodium chloride, 1,000 mils over 12 hours, and the drop factor is 60. So to work this out, I'd first put the hours into minutes. So I do 12 times 60, which is 720 minutes. I then do 1,000 divided by 720, which gives me 1.38. And then you times that by the drop factor, which is 60, which gives me to the closest mil 83. Now to make that a bit easier, I'm going to divide that by 2 to do it in 30 seconds. So it's roughly 41 drops. So I'm just adjusting my lever to put that at 41. And that is correct. All right, my next one is 3.75% dextrose with 0.225% sodium chloride, 500 mils over 12 hours. So I'm going to do 12 times 60, which gives me 720 minutes. 500 divided by 720 is 0.69, and the drop factor is 60, so times 60 gives me 41, 42 drops. And then I'm going to make that easier, divide it by 2 to do it in 30 seconds, which is about 21 drops. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Which is correct. All right, next we've got 5% dextrose with 0.9% sodium chloride, 1,000 mils over 24 hours. So I'm doing 24 times 60, which is 1,440. So 1,000 mils divided by 1,440 equals about 0.69, and the drop factor is 60. So that's about 42 drops divided by 2 to make it a bit easier is 21 drops. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, which is correct. All right, next we've got 3.3% dextrose with 0.3% sodium chloride, 500 mils over 6 hours. I'm going to do 6 times 60 to get the minutes, which is 360. I'm going to do 500 divided by 360, which is 1.38, times the drop factor, which is 20. Gives me 28, divided by 2 is 14. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, which is correct. All right, next we've got 2.5% dextrose with 0.45% sodium chloride, 500 mils over 8 hours. All right, so I'm doing 8 times 60 equals 480. 500 divided by 480 is 1.04 times the drop factor, which is 20, equals 21, divided by 2 is about 11 drops. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is correct. All right, now we're doing the IV fluid. We've got 50 mils of normal saline with 50 units of insulin. Answer the question shown below based on the current rate of infusion of the IV fluid shown on the volumetric pump. So currently the rate is 2 mils per hour. How many units of insulin are being administered to the patient every hour? So I do 50 mils of saline divided by 50, which gives me 1. And 1 times 2 is 2. So that'd be 2 units per hour, which is correct. All right, now we've got 250 mils of normal saline with 25,000 units of heparin. So I'm going to do 25,000 divided by 250 is 100. And how many units of heparin are being administered to the patient every hour? On this pump, it has 15 mils per hour. So I'd be doing 15 times 100 is 1,500 units per hour, which is correct. Same again, we've got 250 mils of normal saline with 25,000 units of heparin. And the current rate is 13 mils per hour. So 13 times 100 is 1,300 units of heparin per hour, which is correct. Same again, we've got 250 mils of normal saline with 25,000 units of heparin. The results of the APTT are back, and the doctor has ordered for an adjustment in the correct infusion rate to 1,000 units per hour. On the volumetric pump above, make the necessary adjustment to set the correct infusion rate in mils per hour to deliver this. So the current rate is 12 mils per hour, which means that the patient will be getting 1,200 units of heparin every hour. If the adjustment needs to be made to 1,000, we would clear that and put in 10, because 10 times 100 is 1,000, and that's correct. All right, we've got 250 mils of normal saline with 25,000 units of heparin. The results of the APTT are back, and the doctor has ordered for an adjustment in the correct infusion rate to 1,500 units per hour. On the volumetric pump above, make the necessary adjustment to set the correct infusion rate in mils per hour to deliver this. So currently the rate is at 12 mils per hour, so meaning that the patient will be getting 1,200 units per hour. If the adjustment needs to be made to 1,500, I would clear that and make it 15, because 15 times 100 is 1,500, which is correct. All right, that is all done. I shall upload this to YouTube shortly and turn it in. Thanks a lot. See ya.